Hi, third graders, welcome back. Today we're going to go ahead and start our new lesson, Area of Composite Figures. This lesson starts on page 797. I hope you guys are having a great day so far. Okay, Area of Composite Figures. Here we go. So, I am up here. Go ahead and read it with me. A composite figure is made up of two or more figures or shapes. To find the area of a composite figure, decompose the figure into smaller parts. And so basically what that's saying is in order to find the area, which we know is the inside of a figure or a shape, we're going to decompose, meaning take apart these shapes to make it easier for us to find the area. Okay, so when you find the area of a composite figure, because we have to decompose or take apart, this is going to be a two-step, actually it's going to be like a three-step process to solve each problem. So just make sure that you take your time and just be patient with it. It's all stuff that you know how to do already. Now it's kind of just putting all these pieces together, okay? So let's see the example one, Math in My World. So example one says shrubs, trees, flowers, and plants can be bought at Mr. Corley's nursery. What is the area of the nursery's garden at the right? And so here they give you a picture of the nursery, okay? Now, I want you to look at that figure, okay, and see if you can find a way that we could split those shapes kind of into nice shapes, okay? Now, when I look at it, I automatically see like a square and a rectangle, because if I draw like an imaginary line right here, I have this square and I have this rectangle. So that's how we're going to decompose these figures, is you kind of want to try to look for shapes that are easy to kind of break them apart, okay? And so step number one says break the composite figure into smaller parts. Look for rectangles because they're easy to work with. And so then step two is to find the area of each part. Now, here they have rectangle one that they split up, which would be this area here. And I know that because you see how they have 8 yards, and this is 8 yards, and then this length is 10 yards. Okay. And then in this rectangle, we have 12 yards and 8 yards. Now remember, this is the area. We're figuring out the inside, okay? So remember, perimeter is the outside. This is the area, and we're trying to figure out the inside. And so we know, because of the previous lesson, that in order to find the area, oh, there goes my pen. Okay. In order to find the area, the formula for area is, come on, let me hear it. Oh, yes. I'm glad you remembered. Area equals length times width, okay? And so here, oh, look, they gave that to you. Area equals length times width. And so they replaced it, like we replaced it during the last lesson. Area equals 10 times 8. And so the area equals 80 for this first rectangle number one. So let's go ahead and write 80. Now, the cool thing about finding the area is, you know how the formula is area equals length times width? So you're multiplying two numbers. Now, let's say you're like, well, I don't really know which one's the length and which one's the width. 10 times 8, 80. 8 times 10, 80. You're going to get the same number. So don't worry too much about that, okay? But technically, the formula for area is length times width. Okay, so now let's look at rectangle 2. So area equals length times width. So that would be 12 times 8. And so here they're doing a little bit of distributive property, which we skipped that last lesson. But we've done distributive property in class. We actually did a lot. And so here, in order to make it easier for them to multiply, because 12 times 8, you're like, I don't really know my 12s yet. So they decomposed the 12 into 10 and 2, and then they multiplied both numbers by 8, distributed property, like we did before. And so now it's easier to multiply because I made my numbers smaller. And so 10 times 8, we know is 80. Where am I? And then 2 times 8, 16. And so 80 plus 16, 96. Okay, so now, oh wait, hold on, they're not there yet. So the area of rectangle 1 is 80 square yards. And the area of rectangle 2 is 96 square yards. And so now we have the area of one rectangle and the area of both rectangles, but the area of the whole figure is what we want to know, right? And so in order to get that number, we're going to have to do what with the area of both of these figures? Add them. You're right. We have to add them. Okay. So here they have 80 plus 96. Now, if you need to, or if I need to, I'm going to stack these up vertically so that I can add. So 0 plus 6 is 6. 8 plus 9, well, I know that 8 plus 8 is 16. Plus 1 more, 17. And so the area of the composite figure is 176 square yards. Okay, all of that for one problem. Okay, so as you've seen, it's not exactly difficult, but it is kind of a lengthy process. So just make sure that you're careful because, you know, if you do one multiplication wrong when you find the area, length times width, you know, your whole thing will be wrong. So just make sure you take your time. Okay, go ahead and turn the page. And so now let's look at example 2. Looks like some curtains. Doesn't that look like curtains? Okay. So example 2 says find the area of the composite figure. So step 1, we're going to break the composite figure into smaller parts. Look for rectangles. Why? Rectangles are easy. Okay, that's why. So if we see here, we can break up this composite figure into rectangles. It's actually kind of like marked off for you already, right? And so this composite figure can be broken into 1, 2, 3 rectangles. So let's go ahead and write 3. Okay. Now here is where it gets a little tricky. And I'll tell you why. Okay. So rectangle 1, they labeled rectangle 1 as this long one at the top. Okay. And it is 12 meters on top. We know that. 12 meters on top. But when we look at the side, like, look at this. Get real close in your face here. Okay. So here is the 12. Let me try to cover my teeth there for you. 12. Now, we know that number for the rectangle, but what about this length here? Well, we know that this length here is 10. See how it tells us right here? But do you see how there's an 8 meters and it's pointing to this? So this is telling us that this area right here is 8. And this whole area here is 10. But I don't want this whole side. I just want from here to here. So if this is 8 and this is 10, then that means this little area right here, I'm going to take 10 minus 8, and that would be 2. So this area right here is 2 meters. And so that's why they gave you the 2 meters, or the 2 meters right here. So it gives you the little note in the bubble that says 10 minus 8 equals 2. Okay, so you're going to have to look for that in a lot of these problems that you're going to be doing on your own. So make sure that if you need some help, you can go back to this part of our video and rewatch it because it can be a little tricky. And so that's rectangle 1. Now rectangles 2 and 3 are pretty simple because they gave us the 3 and then they already told us that this part is 8. Okay, and that's the same for both of these rectangles. Okay, so now we have 3 rectangles. So in the last example, we had 2, and so we just added both of those numbers. But now we have 3 rectangles. So that means we're gonna have to add all 3 area of those rectangles. Okay, so step 2, we're gonna find the area of each part. Rectangles 2 and 3 are the same size. And so we know that to find the area of a rectangle, the formula for area is area equals length times width, okay? And so for the first rectangle, that will be 12 times 2. Here they use the distributive property again to break up that 12 to make adding a little easier. But if you know that 12 times 2 is 24, then you could skip the distributive property and just do 12 times 2 equals 24. So here we're going to use a distributive property just because they already have it written down for you. And so they broke down 12 into 10 and 2. So 10 times 2 is 20. And then 2 times 2 equals 4. And so 20 plus 4 equals 24 square meters. Now for rectangles 2 and 3, the area equals length times width, and so that would be 8 times 3, and so that would be 3, 6, 9, 12, 15, 18, 21, 24 square meters. Funny. 24, 24. 12 times 2 is the same as 8 times 3. Okay, so don't forget though that we have 2 rectangles, but they're both 24. So really we are adding 3 numbers, but we only found area times length for 2 because 2 and 3 are the same, okay? So we're gonna add the areas, which is 24 plus 24 plus 24. Line those babies up vertically if you have to. And so we'll do 24 plus 24 plus 24. So 4, 8, 12, 2, 4, 6, 7. So that is 72. So the area of the composite figure is 72. Okay. Lots of steps, but that's okay. Okay, you could do it. They're not hard steps. They're just a lot of steps, okay? Step number 1, decompose the figure, take apart the figure. Step number 2, find the area of the figures. Step number 3, add all those areas together. Okay. All right, so let's look at guided practice. Find the area of the composite figure. Show your work. So I want you to go ahead and do this on your own. So I want you to press pause, and then when you are ready, go ahead and press play. Okay, I hope that was pretty simple for you, but it's okay if it wasn't. Okay, here we go. So guided practice, find the area of the composite figure. And so here, the first step is to decompose our figure. And we know that we want to look for rectangles because it's easy to find the area of a rectangle. And we know the formula to find the area of a rectangle. So I'm going to go ahead and split mine right here. Now, I split mine up right here, but you could have split yours right here. Okay, there's more than one way to decompose your figures. And so then that means that I have this rectangle and that square rectangle. I made it more of a rectangle, but it's more of a square anyways. Okay, so here, this area is 5, I know that, but here's where it gets a little tricky, because if you see from here to here all the way across is 7, but I don't want all the way across. I just need this area right here, but it tells me that this area right here is 4. Okay, so I have that. So this would be 4. Okay. Now I'm going to look at this square or rectangle. I know this length is 3 because it tells me that, so I'm just going to write my 3. Now I need to find this part though, right? So this part is 7 and this part is 4. So that means this part has to be 7 minus 4, 3. 3. So now I'm going to go ahead and multiply. So 5 times 4 is 20. And 3 times 3 is 9. So 20 plus 9 equals 29. So the area is 29 square centimeters. Now go ahead and do the the independent practice 799, page 799, 800. And if you guys have any questions, please feel free to ask me during office hours or even during our directed drawing time on Wednesday. That kind of got combined to office hours / directed drawing. And so if you guys have any questions, please ask me. I miss you guys. I can't wait to see some of you during our Zoom. I hope you have a great day. See you later.